right in the middle of looking at some riveting videos on how to name things. And of course, the Latin term for how to name things would be nomenclature, just naming stuff. So we're going to talk a little bit about polyatomic ions, because in a minute, you're going to be talking about ionic compounds and these polyatomic ions, and we haven't really discussed what these are yet. So we need to know what a polyatomic ion is. So the definition is right in front of you. This is a group of atoms. Notice it's not a group of elements, although it usually is more than one element, but it is more than one atom that are going to be covalently bonded, but carries a charge. And right below it, I have a definition of a molecule, because that's what we're thinking of. And that's a group of atoms that are covalently bonded, right? Same thing, but has no charge. So the way we have charged species in chemistry is we gain or lose electrons, whether we're talking about a single ion, a metal one, a non-metal, cation, anion, or polyatomic ions. Each atom comes in with a certain number of electrons, and if you gain or lose electrons, you're going to have a charged species or an ion. So some basic definitions. We're going to have valence electrons are going to be electrons in the outer energy level. We haven't really discussed what an energy level is. Typically, you think of these as circles around the nucleus, and that's fine for now. Just be aware that they're going to be the outer one. If you have an energy level of 1, 2, 3, and 4, well, 4 is the outer one. If you have an energy levels of 1, 2, and 3, 3 is the outer one. And the maximum number of valence electrons will be 8. You can't have more than 8. You can have less than 8, but not more than 8. For the most part, atoms want to gain or lose electrons to have 8 valence electrons. So here's a covalent bond. So bond is going to be right here. So bond is going to be defined as a strong attraction. Co means we are sharing. Sharing is caring. That's what we always say. So co means sharing. And what are we sharing? We are sharing valence electrons. So that's how you make a covalent bond. Now, when you make a polyatomic ion, you have them covalently bonded, but overall you have 1 extra, 2 extra, 1 less valence electron. So up here is showing you, this is kind of a cart before the horse. We'll get to electron dots later, quite a bit later actually. So I don't expect you to fully understand this yet, but the oxygens are going to bring in 6 valence electrons, right? So 6 valence electrons they're going to bring in. You got 1, 2, 3, 4, 5, and 6 because it's in group 16, so that's going to be 6 valence electrons. If it was in group 15, it'd be 5 valence electrons. If it was in group 3, it would be 3 valence electrons. Oxygen is in group 1, and therefore it's going to bring in 1 valence electron. Now, if you do the math, 1 plus 6, the 1 for the hydrogen and the 6 for the oxygen equals 7. And ooh, everybody wants to get 8 valence electrons. They want 8 valence electrons. How do you get 8 if you have 7? You gain 1 more. And as we discuss this further, this is going to go into stability, which we're not going to discuss now. But everything wants to be stable. If it's unstable, it's going to react and fall apart. So by adding this 1 electron, and we're not going to discuss where it comes from, you don't just make it, you steal it from something else. Now you're going to have 8 valence electrons. So the oxygen has 8, the hydrogen has 2, and the hydrogen's on the first row, the first period, and therefore it only wants 2. Again, a later discussion. But we have shared this pair of electrons right here. That makes it a single covalent bond, which is also shown right here as a single stick. But in order to do that, we've had to gain an electron from something else. And now that we've gained an electron, this thing is going to be charged. You need to know for nomenclature is hydroxide is going to be viewed as a single thing. Even though clearly it's made of 2 things, we don't name it hydrogen and oxygen it's going to be named as a single item, and it will be viewed as one single item. And this one item, called hydroxide, will take a -1 charge. We would say 1 minus, but it's a -1 charge. So now, if you are needing more negatives, you can add more hydroxides. You can't add more H's or more O's. You have to add whole pieces of hydroxides. So you can have 1 hydroxide or 2 or 3. Whatever you need to make the charges match is what you need. But they will come, you can't split the polyatomic ions in 2 within a single compound. There is the only polyatomic ion that's a cation that you will deal with for the most part. They do exist, other ones do exist, but this is the one that you'll see often, and this is called ammonium. So this is going to be the ammonium ion. And an ammonium ion is going to be an NH4. It's going to carry a +1 charge, so we say 1 plus, and you can have 1 of these, or you can have 2 of these, or you can have 3 of these, that kind of thing. But they will come in groups of 1 nitrogen and 4 hydrogens, and the name is not nitrogen, tetra, blah, blah, blah. The name is ammonium ion, and you can't split it when we're talking about compounds. So let's look at another one. You see often, it is called nitrate. A nitrate is an N and 3 O's. So you can see the representation here is there's nothing here, it's an understood 1. The 3 is supposed to be, it's kind of not really, a subscript over here, and that's referring to the thing right in front of it. And as you can see over here, we have 1, 2, 3 oxygens and 1 nitrogen, but it's going to act like a single thing, and that single thing is called nitrate, and it's going to have a 1 minus charge. Let's look at another one. Here's peroxide. Most of us call hydrogen peroxide, which is going to be H2O2, we call hydrogen peroxide peroxide, but the actual peroxide is only the polyatomic ion, and it's going to be O2 with a 2 minus. This is also a really good example of how you don't need 2 elements. We have oxygen and oxygen, but because it is covalently bonded, there's a single covalent bond because they are sharing 1 pair of electrons. We don't call it oxygen. Now, oxygen that we breathe is actually O2 because there's 7 diatomic molecules. But in this case, this is O2 with a 2 minus. It's a polyatomic ion, and therefore it has a single name and will come in increments of O2 with a 2 minus. You can't say O3, that's something different. And if we had 2 of these, we wouldn't say O4, we would have the parentheses around it like this, and then a 2 behind it. You can't say O4 because you need groups of O2. Helped a little bit. Again, the idea is that we don't name each piece in the polyatomic ion. It has an overarching name. You will have this, these polyatomic ions on the back of your periodic table. Here's the list that you will get for every test this year. If you go into IB, you don't get this list. But for first year chemistry, we give it to you so you don't have to just memorize it. There's a couple of things right here. Right here is our nitrates. Peroxide's not on there, but you can see how it would be in this column somewhere because there's a 1 minus. We have the nitrates. There's a bunch of common ones you may have heard of, like here's carbonate. But anyway, these will come in increments of, in this case, like the carbonate, a CO3. And you may have 1 of them or 2 of them or 3 of them. But if you have 2 of them, we would represent it by a CO3 in parentheses and then a 2 behind it, because we can't just add to the pieces here. It would be 1 CO3 or 2 CO3s, and we have 1 carbonate or 2 carbonates, etc.